Okay, good morning, good evening. Welcome to
SuperMath number 71.
SuperMath71. I was traveling today, but I had to work through a few problems in the challenging problems section. So not the challenge problems, the challenging problems in our chapter about triangles. And one of them was about finding the radius of the circumscribed circle of an isosceles triangle. Do you remember that?
Yeah.
Okay. So we're going to try to work through an example here and just see how it goes. What do we know about the circumscribed circle?
Well, we know how to find the center.
Okay, where is that going to be?
So we can draw the perpendiculars, the bisectors.
The perpendicular bisectors, okay. So why don't you sketch about where those are going to be?
And then they meet sort of around there.
Okay. Anything else to add to the picture here to make it a little more understandable?
Well, this part, this is the radius. It's from the center to the vertices.
Okay, very good. That's the radius, but that's exactly what we're trying to find. Good job. That's a great thing to notice.
So I think what I'm going to do is I'm going to use this right triangle.
Okay.
Here.
All right.
So I know this is 5, but we need to find out what this is.
Yeah. That's the tough part.
Well, I know the whole height is 12.
Okay.
So what else can I say? Well, I know the area of the triangle.
Okay, you know the area, yeah. But we haven't yet said, there is actually a really interesting formula for the area of a triangle using the radius of the circumscribed circle, but we haven't talked about that yet.
Well, I think there was one with the radius of the inscribed circle.
Yeah, there's also one with the radius of the inscribed circle, which is, we have talked about that one. Alright, so you've drawn enough actually here to solve the problem, believe it or not. So what do you want to do? Let's talk about what we know here. Let's review what we know and what we don't know.
Well, if we could find this length, that would be the key.
Okay, good. So that's the length we're looking for.
Or if we could find this hypotenuse.
Well, okay. If we could find the hypotenuse is going to be exactly what we're looking for.
So I'll call the hypotenuse R. I'll call this X. And actually, I'm going to call this X and this 12 minus X.
Okay. Very good.
So we can do the Pythagorean theorem. We get 12 minus X squared plus 5 squared equals R squared.
Okay, very good.
So we could work out what this is.
Yeah, but we have two variables here and only one equation, so that's probably not going to be quite enough. But look at the geometry here, because you're on the right track. Look at the geometry here and see if you can find a different relationship between X and R.
They're the same.
Why?
Because they're both the radiuses of the...
Ah, how interesting. So what does this equation actually become now?
So it's 12 minus R squared plus 5 squared is R squared.
Okay.
So then we can work this out.
All right.
We get 144, 12 squared.
Yeah.
Minus 24 squared, 24R.
All right.
Plus R squared.
Okay.
25 plus.
Okay.
And then equals R squared.
All right, very good.
So we can say this is 169 minus 24R is 0. Subtract R squared.
Okay, combine those two terms, we'll get 169. You mind filling in that 9 just to end the 6? 169 equals 24R. Or, sorry, 169 minus 24R equals 0.
Well, 169 is 24R. So R is 169 over 24.
All right, very good.
That's not really going to cancel.
R equals 169 over 24. How do you know that doesn't simplify?
Well, because this is 13 times 13, and that doesn't have any 13s.
Very good. Very good. So we just found the radius of the circumscribed circle is 169 over 24, and that doesn't simplify. Now, even though we don't know enough to talk about it yet, but I'll tell you what the formula for the area formula is. It says area is A times B times C.
Oh, those are the sides?
Yeah, area over 4 times the radius of the circumscribed circle. Or the radius of the circumscribed circle is A times B times C over 4 times the area.
Yeah, you just cross and multiply.
Yeah, so you told me you knew what the area was because the base was 10 and the height was 12. So what's the area?
The area is 60.
Okay, so we get 4 times 60 on the bottom, and then we get 13 times 13 times 10,
Well,
right?
Yeah. So it's like, that's all that can cancel. So you get 169 over 24.
Just like we got. This is a neat formula. This comes from trigonometry, so
We don't
We-
know about that.
got a little bit more to study with triangles and stuff before we talk about this. It's probably actually going to be a couple of years down the road, but it's a very cool formula for the radius of the circumscribed circle. And you can see in this case it worked, and your way of doing this for this isosceles triangle is really good. So good job. Good job, Nathan.